Hello. Today we are going to demonstrate how we can create functions in R. R as a program comes with many functions. The functions that allow you to calculate the average, the standard deviation, you plot a graph, you bring in a shapefile, you create a matrix, you create a data frame. These are all functions of R. Also, you can create your own functions within R. So today, we do a little bit demonstration to see how we can create some basic simple functions within R. Now, you can go to the course site to download the instructions of the lab. Also, download the R script functions of R 2020. Okay, so this is that script. So now let's look at the first issue: functions with one explicit argument. Argument here is also the variable. Now here, this is the statement of function. Statement of function have to start with a function, this word, the keyword function, followed by parentheses. And when we say explicit argument, here x is explicit argument. This is a variable that comes with this function. Okay, so this is statement of function. Statement of function is followed by this writing that you tell that within this function how this variable x is going to be used. In this case, I will use this value of this variable plus 2. So that's how we define this function. The function is simply the value of x plus 2, or 2 plus the value of the variable x. So we define this function and assign this function into the three letter words fun. That means function. Okay. We just define this function in this manner. Let's run this fun to see what's inside. So that gives you the exactly same thing. Function x defined as 2 plus x. That means that this function is add 2 to whatever value of x. Okay. So after you run this function, you're going to actually use this function. Within the parentheses of this function, you put in the value of x. And obviously, this means that you're going to add the value of x 4 to this constant 2. Okay, so this had to be 6. Okay, so 6. Now let's see, the value of x is 20. So that means that we use 2 plus 20. Okay, because now we define the value of x is 20. So that's 22. Okay. So that is give us a sense of how we simply define a function in R. Now let's next one. This function a little bit more complicated, and this function, this is the statement of function, and within the statement we have a variable called temperature subline f. So temperature measured in Fahrenheit. So this function is to convert the temperature in Fahrenheit to a temperature in Kelvin. That's why the name of this function is Fahrenheit to Kelvin. And so this is the variable temperature measured in Fahrenheit. And this equation tells us that how we are going to use this variable temperature measured in Fahrenheit. This is so temperature measured in Fahrenheit minus 32 multiplied 5 over 9 and plus 273.15. So this is how this equation defines how we are going to use this variable temp f. And we assign this calculated result to this new term we call temp subline underline K, so temperature measured in Kelvin, and we are going to ask this function to return the value of temperature measured in K. So here we have a slightly different way to define this function, because in this function there's more comes with it, therefore we need a larger space. So we use a curly bracket and to create this space to define the body of this function. Okay, and after we define this, we give this equation, define this equation at time k, we need to return the value of k, and that's how we define this function. Okay, so after that, you simply, again, you use the name of this function, Fahrenheit to Kelvin, and within the parentheses, you put in the value of this variable temp f, and that should give you the value of temp k. And that is, so you provide temperature measured in Fahrenheit 32. That should convert into a temperature measured in Kelvin 273.15. Okay. You know, this so far we see the two. It appears to be a two different way to define the R function. Actually, they are equivalent. We can change the first way to define a function into the second. At the same time, we can also convert the second way to define the function into the first. Let's do this. Okay. This function we can copy this. We can copy this to a new place here. Okay. So we can have the statement of this function. Then we have this body of this function. Then we define a value of y, this value equal to this equation 2 plus x. After that, we're going to ask this function to return the value of y. And we'll finish this body of function by using a curly bracket. Okay. So now you can really see that we change this way of defining function into a second way of defining function. But if you use the second way to define the function, you have to ask this function to return the value of y. Let's run this function here and provide a value of x, and you should get a value of y. Now let's see how we can change this format of a defining function into the first format. Okay. So now what we need to do is we just after we have this function statement, we place this body of function followed by the statement. Okay. And so this is the whole formula is the way we decide that this is how we're going to use this variable temp underline f. We get rid of these two lines. Okay. Now let's run this. Run this function. See, this function looks exactly the same as the way we defined the first function. Okay. They are equivalent. So let's run this line. After that, we provide the value of variable temp underline f 32. We run this line, we get the same result. So two ways to define function are actually the equivalent. Okay. Now this in the next function, we have this variable x, but in this expression, we use x in a more complicated way. 3 multiplied x plus 3 multiplied x raised to the second power. Okay, and then we define this function 1. Then we provide the value of x, 3. In this case, we know that since the value of x is 3, so we expect we have a calculation that 3 multiplied 3 plus 3 multiplied 3 raised to the second power. Okay, so let's run this function. Okay, we have 36. You can see, let's verify this value. Since we define the value of x is 3, 3 plus 3 is 9. Okay, then 3 raised to power of 2, that second power that gave us 9, and 3 multiplied 9 is 27. 27 plus 9 is 36. So we verified the results. So in this case, we only provide one value of x, 3, to the function. We can also simultaneously provide more than one value of x to this function. For example, we can provide value of x 1, 3, 5, 4 respectively into the function. And so when you provide value 1, you can expect this expression is 3 multiplied 1 plus 3 multiplied 1 raised to the second. Then 3 multiplied 3 plus 3 multiplied 3 raised to second. Then when the value of x is 5, you can imagine it is 3 multiplied 5 plus 3 multiplied 5 raised to the second, then followed by 4, and 3 multiplied 4, and 3 multiplied 4 raised to the second. So let's first define this vector d, and we provide the values from d's into this equation 1, 3, 5, 4. So we should expect the 4 value as a result. So that's exactly what happened. Next, move on to the second topic, functions with more than one explicit argument, with more than one variable. Here, we have a function that within the statement, we have two variables, x and y, and followed by this expression tell us how these two variables are going to be used. So we 2 plus x plus multiplied y. So we assign this function to function 2. Then we provide the value of x and y. Within this statement, x is the first and followed by y. Therefore, within this function expression, the first value also expect to be the value of x. Second value is expected value of y. Okay. So if we provide value of x is 4, value of y is 10, so in this expression, you are expecting is 2 plus 4 multiplied 10. So that this part is 4 multiplied 10 is 40 plus 2. You should expect this result is 42. And that's exactly what happened. Next function, you have three variables, x, y, and z. And this tells us how the three variables are used. So x multiplied y and plus z divided by 3. So we define this as the function 3. Then we provide the value respectively to x, y, and z. X is 4, y is 10, z is 4. And supply these three values into this equation, you should expect this value that comes as 43.333. Let's now define some new functions here. Let's how about we define a function we call average. Define average. Okay. This function is average. And how we calculate the average? We define that as function that involved A, B, C. Okay, A, B, C. And how we define this? What is the way we calculate the value, the average value from A, B, C? Let's use this way to define the average. We call it mean. Mean is defined as A plus B plus C, and then they are divided by 3. And since we defined with this curly brackets, we also need to return the value of mean. Okay, and that finish and close the curly bracket. Then we just look at average. We can average this function divided by, we have provide the value of a, b, and c. Okay, so this average. Okay, average. Okay. So this is how we define average. Okay. Let's see how what within average, that exactly what we expect here. So you need to provide the value of a, b, and c, and this function would put the three values together, divided by 3, and return the mean value. Now let's give the value of a is 3, value of b is 200, the value of c is 1000. So that's we can calculate this average. Provide this. Here we go. You have the average 401. So that's how we define our own functions. Now, this interesting case is functions with x as input. Okay. Now we define this function within the function statement. We have 3 variables: u, verb, and home country. And then within this body of the function, this is we state how we use these 3 words. The first variable go first, second variable followed by second variable, and followed by third variables. And we call this arrangement statement, and we want to return the statement. Okay, so let's run this function. Run the function, then we're going to define the value of the three variables. Okay, so we first define a character called I. Okay, then we define the character called act. Then we define next character as at home. So the value of this variable is I, and I defined as me, and we define act as love, define home as USA. Okay, so these are the value of 3 characters. Now, since we define origin already, so we're going to put the value of 3 variables, u, verb, and home country, into the parentheses. So depending upon what statement you want to make, so if you want to put me at the first, act at the second, and home and the last, this means that you use me to define as the value of you, define act as the value of verb, and use home as the value of home country. Now let's see what happened if you run. Let's see what statement we can obtain. Okay, let's run this statement. You can see I love USA. Now you can also run this differently. Okay, you can say that I am going to put home first and put me and in the last place. This means that you're going to define home as the value of you, and act as the value of verb, and me as the value of home country. Okay, let's run this. See what we get here. So what you get here is USA love I. So that will give you a sense of we can also use our functions to work with characters. Now we have functions that are kind of nested within each other. That's why we say functions within a function. Now let's first look at this function. Make power. So you have one function that defines one variable n, and within this function, this is a curly bracket here. Within this curly bracket, we have another function. This function is called the base. This function comes with the variable x. Okay, within this body, within this curly bracket, we define how these 2 variables are used. We use x as the base. That's why this That's why the variable x come with the second function. That's why the function is called base, because this variable is going to be used as a base of a value. And the first variable n is used as an exponent. Okay, so this equation expresses how the two variables are going to be used. So let's define this function. After that, we are going to first. So this is how this is market power. Market power is function. Within market power, it requires two values: value of x and the value of n. Okay. Now let's first define the value of x. Okay. So this is what we do it. So if you create this, let's do this. The market power parenthesis 3. This is to define the value of base. Define the value of base. Okay. So you run this. Define the value of base. Okay. So that give you don't know what it's about. But if you define, you assign this expression to the cube, then this means that we set the base to 3. We set the base to 3. Okay. Okay. Then we, within the make power function, we put in value 2. This means that we set the base to 2 squared. Okay. So now we define the two separate functions by these two expressions. One function is we have a base 3. Another function is a base of 2. Both of these two expressions by themselves are also functions. Now let's see that we use the cube. We know the cube is to set the base at 3. So if base is 3, we give a value of 3. That means that we set the power. So this value is for power. We set the power to a base of 3. Set the power for function for base 3. You run this, you expect to get 27. So because you have a base 3, raised to the third, you 3 multiply each other 3 times. That give you 27. But for square, you raise to the third. That means square, we know the base is 2, and you get with base 2 the third power. That means you 2 multiply each other 3 times. That you can expect this give us the expression of 9. Okay, so that is how we deal with a situation where we have a function within a function, nested function. Okay, now let's skip this. Now the more interesting is we can use a function to replace a for loop. We have learned for loop before as this one. This is an example of for loop. We want I to run this indicator. I run from 1 through 10. Every time when I take a particular value, the I will raise to the second power. So in the first time when I is 1, raised to the second power, that is 1, and that will print out this. We define this value as y. That will print out the value of y. Second time when the i's value is 2, 2 raised to the second power is 4, and will print out this 4. And next time when i's value is 3, 3 raised to the second power and 9, and will print out 9. So we run this until we get the i's value is 10, and raised to 10 raised to the second power 100. So we learned the for loop before. If you run this for loop, you expect to see this. This is every time when I take a different value, sequentially it raised to the value to the second power. We can do the same thing with the function. Okay, now let's look at this. We define this function as this. This statement, and the variable is x, and the x value expect to raise to the second power. And we define this function as function loop. After we define function loop, we provide 10 different values for x from 1 through 10. The first time when what the value of is 10 is 1, and the 1 at the value of x raised to the power of 2. And the second time when the value is 1 through 10, the second time when x value is 2, and the 2's value raised to second power, and the third time when the value of x is 3, and the 3 value is going to raise to second, so on and so forth. Okay, and to make the situation more similar, let's define this name of variable as I. Okay, the variable's value is simply I, and therefore how we use the value of x, every time when I take a different value, raise to the second. Okay, let's run this. Now let's see what's within the function loop. So function loop requires the value of I, and every time it receives a value of I raised to second power. So therefore now we're going to provide the value of I from 1 through 10. You can expect the result should be the same as we will obtain from for loops. To run this, you have 10 values. The 10 values are the value of I raised to second. Each time I have a value run from 1 to 2 to 3 to 4. So you can really see how we can use the function to replace for loop. Also in the past, we learned that we can place the value from for loop into a matrix. Now let's do that with function as well. Now here, this is for loops, and before we run this for loop, we like to create a matrix. Within this matrix, we have 10 rows and 1 column, and this is empty matrix. And the purpose is we're going to place the value that we obtained from for loops within this matrix. Again, this for loop run from 1 through 10. Every time when I take a particular value, we use the base 3 raise the exponent to the value of I. For example, first time is 3 raised to the first, and second time when I value is 2, we raise to the 3 raised to the second power, and third time when I is 3, and the base 3 raised to the third power, so on and so forth. Okay, so every time we obtain this value, we place that into a row within the matrix. First time the value placed into the first row, second time the value placed into the second row, and third time the value placed into the third row, so on and so forth. Now let's run this for loop. Now let's see what's within this matrix now. So you can see that each row of the matrix contains each value. Now we can do the same thing with this function. Okay, so this function, we define this function as this function statement, and followed by the body of function. Body of function is, again, let's make it just as similar. We define this function name of variable, not x, but a variable I. Okay, variable I. Okay, variable I, you can really see that the i's value, we use the base is 3, and base 3 raised to the power of I. So depending upon what is the value of I, you raise the base to the power of I. And we calculate this value, define this value as y, that will return the value of y. So let's run this. Okay. After this, you can see within this function, we expect the value of I. Now let's provide the value of I. Okay. So let's create another empty matrix. We call it matrix 1. Okay. Now within this matrix 1, we need to run from 1 through 10 rows. This matrix 1 through 10 row, what values we put in, this function is defined as this function. This function requires we provide value of I. Now we provide value of I from 1 through 10. Okay. Now let's one function of function mat, we want the I run from 1 through 10. So we expect that this gives us 10 different results. The result from 1 through 10 we put out into this equation, into this matrix from row 1 through row 10. So if you run this line, so you can expect so let's first run the equation. Let's run this empty equation, create the empty matrix. The empty matrix give us the empty matrix. Now we're going to put the values from these functions into this matrix on different rows. Run this. So let's see what's within this matrix. We have the same result. So that's how we can use a function to replace for loops with R. Okay. Well, so this is a demonstration of how we can create functions in R, and also some very useful purposes of using the functions within R. Now you can follow the instruction of this lab to finish the assignment and turn in the assignment for this lab. Okay, I see you next time. Goodbye.